So this is lesson 79B in Algebra 2, and we're still doing the conversions, and we're going to go ahead and do example 79.3. I didn't see this one, but we are changing 4.7 liters to cubic inches. Alright, so we're starting with liters. We're going to do our crossover. Remember, when we do our crossover, 1 inch equals 2.54 centimeters. So that's how we go from English to metric or metric to English. So we're going to do that, and then we're going to change it to cubic inches. So we'll start with 4.7 liters. So we have to change 4.7 liters eventually to centimeters. So how are we going to do that? Well, we're first going to change it to milliliters, because I know that 1 milliliter equals 1 centimeter cubed. So we're going to change from liters to milliliters, which will go over to centimeters, and then we'll go from centimeters to inches, which will be able to give me my cubic inches. So 4.7 liters, line, liter on the bottom. I know the comparison here is 1,000 milliliters. So now I can cancel liters with those liters. And I keep going here. And I'm going to put a milliliter on the bottom. And do I know anything about milliliters and centimeters? I know there's one of those and one of those. So there's my first conversion. So I get rid of my milliliters. So now I'm in centimeters. Now I have to change from centimeters to inches. And because I have a centimeter cubed, I'm going to have to do 3 lines. Okay? And I have a centimeter here, centimeter, come on, centimeter here. So 2.54, 2.54, and 2, gosh, why isn't this writing? I think I'm wearing my pen out. And this is 1 inch, 1 inch, 1 inch. And my 3 centimeters cancel with those 3 centimeters. So I'm at an inch now. And how many inches do I have? 1, 2, 3. And that's what I was looking here. So I've got my cubic inches. Alright, so how do I write this answer? I'm going to write it as 4.7 times 1,000 times 1 times 1 times 1 times 1. You don't have to write all those ones. Over 2.54 times 2.54 times 2.54, and then that is inches cubed. And that, my friends, is all you need for your answer there. So that's converting. Alright, let's jump to the 45, 45, 90 triangle. Now, we already did one special triangle. It was the 30, 60, 90. And if you remember, and I need a bigger pen, 30, 60, 90 was a triangle where whatever this was, the hypotenuse was double, and this was whatever the short was times the square root of 2. And I told you one of the ways I teach this, and it looks like the book finally maybe gets to this point. I don't remember if they do for sure. Whatever length that is, the length of the hypotenuse is 2 times x, and the length of the other side is x, this length, times the square root of 2. So for example, I know I'm doing 30, 60, 90 when we're supposed to be doing 45s, but it will come. Alright, so let's say that that is 3. Well, my hypotenuse will be 2 times 3, and this other side will be x, 3, square root of 2. Okay, so you can find all of the sides of any triangle based on just one of the sides. Alright, so let's look at 45s. 45s has a very similar method of finding. So we got a 45-degree angle, and this is 45, and this is 45, and this is 90. There we go, 45, 45, 90. Alright, when we know that, if this, whatever length this is, the other side is going to be the same, and this side, or the hypotenuse then, will be the length of that side times the square root of 2. So if this is 1, this is 1, this is square root of 2. If this is 6, this is 6, this is 6, square root of 2. So I have this formula here that whatever length this is going to be the same, and this is going to be the length times the square root of 2. And that's pretty much it for that. If you know that formula there, you'll be good for any of these problems. Alright, so let's go ahead and do the only example that they have here. They have a triangle, and the triangle says this is x, this is y, and this is 7. And what they want you to do is they want you to find the length of x and y. And they say use similar triangles. I think using similar triangles is silly. What we'll do is we'll use this formula. Okay? And go ahead and find x and y. Well, what is x square root of 2? X square root of 2 is 7, right? So what is x? 7 over the square root of 2. And if you remember, you cannot use the square root of 2 on the bottom. You can't have an answer with the square root of 2 on the bottom, so we make a couple changes here. And x is equal to that. Now what's y? Well, x and y, what do I have here? I have x and that. I've got these two being the same. So if x is 7 square root of 2 over 2, then y also has to be 7 square root of 2 over 2. Okay? So let's look at one of the practice problems. Let's look at C, because they give you one that's a little bit different than that, and sometimes these get to be a little tricky. They say that's y, hypotenuse is z, and this is 3, and it's a 45, 45, 90, and they're asking you to find y and z. Well, I know y is going to be 3 because whatever length that is, this is going to be the same length. So what is z? Z will always be the length of the shorter side, well, which these two sides are the same, so they're both the shorter side, times the square root of 2. And that's it. That's a z. Okay, so that's lesson number 79.